Institute of Medical and Biological Engineering is a group of over 100 researchers based at the University of Leeds, with a goal of engineering 50 active after 50. We include engineers, physicists and biologists, and work closely with clinicians and industry to improve quality of life in the ageing population. We have several research focuses, including cardiovascular and spinal interventions, but in this video we'd like to introduce our research into total joint replacement. As we get old, the cartilage breaks down through wear and tear, injury and diseases like arthritis. Cartilage is a tissue which covers the ends of bones at joints such as the hip and knee, and it allows smooth motion of the joint. Replacement of the joint surfaces with artificial materials aims to alleviate pain, restore joint function and improve patient quality of life.
Nowadays, more than 160,000 hip and knee replacement surgeries are performed every year.
The first successful total hip joint replacement was designed by Sir John Charnley in the early 1960s. Clinical results have encouraged its use, and its concept is still being used to date. Nowadays, there are many material combinations that can be used in total hip replacement bearings: metal on polyethylene, ceramic on polyethylene, metal on metal, ceramic on ceramic, ceramic on metal, and researchers are investigating the use of other polymers such as polyurethane and PEEK.
Another type of total joint replacement is the artificial disc. These are used to replace the natural intervertebral disc in the spine. These spinal disc replacements are located in close proximity to the spinal canal. It is therefore of paramount importance that they are tested thoroughly in the lab.
Although the statistics on the success of total joint replacement are encouraging, our aim is to improve this further by understanding why things fail and developing methods to ensure they work in the future.
Studying failed prostheses provide us with information on the kind of conditions that exist in the body, and by replicating that in the lab, we can improve the design of current joint replacement bearings.
Pin-on-plate studies are the first tests we'll do to evaluate new materials or coating. If the new materials appear successful in these simple tests, we can then scale up to a total joint replacement and test it in our simulator. Our wear simulators aim to replicate the complex motions at the joints that occur during different activities.
We can test joint replacement bearings in simulator machines that simulate a gait cycle for millions of cycles, representing years of use in the body.
International standards for new devices require only tests using simple gait cycles. We are focused on developing new simulation methods to represent more demanding activities and better reflect daily living.
We always work on developing advanced simulator techniques that simulate adverse conditions. Assessing the prostheses under these conditions would make sure only the safe ones make it into the market.
We also use sophisticated computational modeling technology so we can understand the complicated mechanics of these artificial joints that helps us understand how they would behave in a human body.
Preclinical testing using advanced techniques to simulate adverse conditions and everyday motions in the lab is essential in developing hip, knee, ankle and spinal joint replacements.
Our aim through our joint replacement research is to achieve safer, reliable and longer lasting implants that benefit patients and allow them to have healthy and active lives.